Our algorithm is the intrusion detection system. Specifically, the problem that we're solving is the machine learning intrusion detection system. Unsupervised learning algorithm can look at the usage patterns in a network, and they can report anomalies without any labeled data set. One supervised algorithm, an example of this is k-means clustering, and it has a labeled data set, and it builds a supervised machine learning algorithm by teaching it the difference between a normal and an attack packet pattern in the network. The algorithm uses collected information and predefined knowledge to reason about the possibility of an intrusion, and it will provide services to stop the intrusions, such as giving alarms, activating programs to deal with the intrusion.
A primary issue with IDS is that IDS regularly alerts you to false positives, thus having your engineers spend time responding to them, which wastes resources and money. This can be an ethical issue because it appears to be crying wolf, and it can erode trust in your system, and then no one trusts your security anymore. A secondary issue of IDS is that an experienced engineer is needed to implement the system, which leads to him having root access and backdoor capabilities and putting a lot of trust in him, which leads to a potential personnel security risk, which is the most difficult to defend against.
The stakeholders for our algorithm are people who use cloud computing technology and also anybody who would be using our networks. So cloud computing technology is a new style of computing that virtualizes all of the resources. It's become a widely accepted paradigm because users can request computing services anywhere and at any time as soon as the internet provides. And this relieves the burden of server and storage management from the user.
A potential bias of IDS is the base rate fallacy. Imagine that a system, when it sees a malicious activity, identifies it correctly with a probability of 99%. This implies that 1% of the time it incorrectly identifies the malicious activity. An administrator might see this as a bias, telling people that their false alarm rate is 1%. However, imagine that with 1,100,000 logs evaluated, 100 are malicious, and based on 99%, 99 will be detected.
The ethical issue of the IDS algorithm is that there isn't a standard set of ethical guidelines that a company's network administrator has to follow. The results of this impact are that IDS requires ethical codes to be reached. An example of how stakeholders are affected by the outcome of this algorithm is that if the algorithm sees any red flags that can be reached by unauthorized users, the results of this could be significant and damaging to the company. A way to minimize the negative effects of this algorithm is for the network administrator to notify that their job process has been stopped by an IDS.